Hello everyone, my name is Austin Shaner, and welcome back to my channel. We've finally reached the last episode of how to build a guitar in Fusion 360. For those of you who followed the series from the beginning, first of all, thank you so much for the support and time that you've invested into this. And secondly, congratulations, because I do realize that my videos can be quite long and they can be quite tedious to get through. So everybody who took the time to watch it and learn, I really appreciate it. So what have we covered so far? In episode 1, we covered the foundational sketches and why it's important to lay a good foundation for your design. In episode 2, we did our first extrusions and then kind of detoured and covered the basics of lofting so that we'd be more prepared for the more difficult contours down the road. In episode 3, we actually contoured the body and the neck transition. In episode 4, we went through the different kinds of strategies you can use to get good results on a headstock transition. In episode 5, we powered through the truss rod, fretboard, nut, and bridge. And finally, in this episode, we're ready to start buttoning up this guitar with hardware such as pickups, output jacks, control cavities, knobs, tuners, etc. So that's a lot to do, and that's a lot to get through, so let's not waste any more time, and let's get this started. Okay, so just like in episode 1 where we laid out some foundational sketches, let's go ahead and do the same thing but for all of our hardware and controls. So that way we only have really one major sketch, and so we're not creating 30 new sketches in this design. So let's go ahead and sketch on the top surface, and let's lay out our tuners first. So if I hide my body, actually I need that, project in these two lines. That, and I'm going to offset these by 0.375 inches. It might need to go a little bit further than that, but that's okay. I can always go back and update it. Offset by 0.375 inches. That's going to be our center line that our shaft is going to ride on. So let's go ahead and give ourselves some holes. Make that coincident. Okay, we need to make all these equal. And let's look at our tuner real quick and see what the outer dimension is of this shaft, which is 10 millimeter. But actually, what we're really concerned about is this one. We need both, but so the outer diameter of that is 15.5 millimeters. So what I'm actually going to do is create two circles on one of them. That'll help us figure out if the 3.375 is right. So 15.5 millimeters. And then we've got 10 millimeters. So see, we're good. So it's not breaching outside of the outside of the headstock. So I'm just going to make that a construction line. And then what we need to do is dimension from here. Let's bring our body back to here, 0.75 inches. So that's our first one. I made these coincident with the bottom. I did not even notice that. So circle, circle, circle. Make these all equal to this one. Make this one vertical to here. This one vertical to this one. And this one vertical to this one. Okay. So now they're riding up that chain and they're staying vertical to each other. So bring the body back and let's go 0.75 from our smallest. And then let's make this a midpoint between those two. So let's go ahead and draw a line here and a line here. Make these construction and make them equal. So that guarantees that it's going to be the midpoint between all of those. So you imagine we could just take those, even though it's sitting on a plane a little bit higher than the actual surface, we can cut all the way through it. So that's the sketch for our tuners. And now let's work on the bridge. Sorry, I didn't mean bridge, I meant the pickups. So if we go to EMG's website, on their website, they've got the cutout dimensions that you would need, and they also have the dimensions of the faceplates And on the actual instructions for the pickups, they've got the dimensions of the pickups itself. Now, I went ahead and grabbed a model from GrabCAD that's pretty accurate, close enough for what I'm doing anyway, but mostly what we're going to be doing is drawing a sketch based off of what we see here. So let's go ahead and go back and let's make a rectangle and another rectangle. And let's dimension it. Let's bring in this right here to give ourselves a dimension off of the fretboard of, let's say, 0.25 inches. Actually, I'm going to make that a little bit bigger, 0.5 inches. And then let's, actually, I'm going to delete this one. I'm going to delete both and make them a midpoint rectangle. Like that. Dimension off of here, 0.5. Again, we can always come back and update this. And what do we need that to be? We need that to be 1.6. And we need the length to be 3.37. Okay, and we want to make sure this is a midpoint. So we can create a real quick construction line to the midpoint of our fretboard. Make that horizontal. Okay, so that one is locked in. And then we need the, actually it was 3.37 to the outside of the long one. So I need to get rid of that. 3.37 inches. And this one is going to be shorter. So 2.84. Like that. And what's the width of this? 0.9. So this one's going to be 0.9. Okay. So there's our first sketch. So let's go ahead and highlight all of that. Copy, paste. Bring that over for our bridge pickup. It kept all of our dimensions and relations. All we need to do is dimension between them. Make that horizontal. And let's give the center point dimension of 3 inches. Now, of course, I can always go back and update that, but that should work for now. Okay, so those two are done. Now let's figure out where we're going to place the knobs. So let's go here and here. And we need to look at our potentiometer to figure out what that hole size is going to be. So let me go over to the potentiometer I'm going to be using. And let's see the depth. 6 millimeter, basically 1/4 of an inch, which is good. That's the size of our laminated top. And the diameter is 9 millimeter. So let's come over here, make that 9 millimeter. Make these equal. Okay. Now let's also give ourselves a construction circle so that way we can see the general size of the knob. So here's the knob that I've pulled off of GrabCAD, which is going to be similar to what I want. So I want to see the diameter. It's going to be kind of hard to measure off of this, but it looks like there's a point that's straight vertical. Yep, 19 millimeters. Okay. So let's come back and dimension this as 19 millimeters. Oop. Undo. There we go, 19 millimeters. And make these two equal. Okay, now we just need to position them. So let's put this one, let's project in this point right here. Actually projecting that line. Draw that to there. Make these collinear. Okay. And then let's give ourselves a construction line here. Say we want these, undo. We want these to be 1.5 inches apart. Actually, I think we want them to be greater than that. Let's make these 2. Okay, and then we can kind of figure out the angle So right about there looks pretty good. Let's make this a little bit less, 1.75. That's looking a little better. Okay, and I want that to come in 1.5. Yep, that's looking pretty good. Okay, and then we still have our angle adjustment here. So let's give ourselves an angle, 135. It's basically a 45-degree angle if you were to come this way. Okay, so let's see, we've got that. Let's hide our bodies and see what we're looking at here. Okay, so we've got our headstock sketched, our pickup slot sketched, and our knobs sketched. So that's looking pretty good to me. The only thing kind of remaining is the toggle switch. Sorry, it took me a second. It's getting a little late. So let's look at our toggle switch on StewMac. So this uses a 1/4 inch mounting hole. So we need a 1/4 of an inch hole, 0.25 inches. Now where are we going to place that? So I could place it back here, or I could place it up here kind of like a Gibson. So let me think for a second. Yeah, so I think I want to place it over here. So what I'm going to do is give myself another construction line between here and here. Let's go ahead and make these perpendicular. And let's make this come out about the same distance. 1.5. That's looking pretty good. Okay, so I'll have my volume knob and my tone knob and my selector switch. That's looking pretty good. Now, what I'm going to be doing for the jack is I'm going to be using an N-pin jack, kind of like what you see on acoustic guitars where your strap actually connects to it. So if I bring back my body, that's going to be going through this wall right here, tangent straight into the body. So that way we can have our pickup, or not our pickup, our control cavity kind of come down like that and not have to sweep all the way across into the pickup area. We're going to end up cutting some channels from the pickup area to route our cables through to there. So that's looking pretty good to me. So let's go ahead and cut. So let's grab our tuner holes and cut through to the back of the headstock. Oop, I didn't select this one. Undo. There we go. To object, back of the headstock, done. And let's bring back that sketch. Actually, we still have it up. Okay. Now we need to cut the pickup slots. Actually, before we do that, let's go ahead and grab these ones, since these are pretty easy. Cut through, and let's hide our main body. And I'm only going to be cutting these through to the laminated top, because I'm going to have a cavity in the back that will come all the way through to the laminated top. So that's the amount that it's going to be holding on to. That's a 1/4 of an inch, which is the amount of thread available on those as well. So that works out nicely. So let's cut that through. Okay, and then the last thing is we need to cut the pickup slots through both. So let's select these. Now, when you cut these down, you've kind of got a couple different options. So if you're going to be hard mounting your pickups, 0.75 seems to be about the right amount to bring it down. But when you're hard mounting, you kind of need to figure that out ahead of time, because you won't really be able to adjust the pickup very well unless you put in some kind of like sponge padding or something underneath to kind of act as a spring. So if you're going to be hard mounting, make sure you kind of know what the distance you want from the top of your bridge to your strings is going to be, and then go from there. If you're going to be using the mounting plate for the bridge, or not for the bridge, for the pickups, then 0.75 seems to work pretty well. Now, they do recommend on many websites that you actually cut an extended slot down for these, for like the mounting feet on the pickups. I don't find that particularly necessary because, at least with humbuckers, because active pickups tend to want to sit closer to the strings than passive pickups. And so you're actually going to end up with probably quite a bit of breathing room, even if you mount it at 0.75. But if you're really concerned about it, then you can go ahead and extend that down if you feel like you want to have more room to pull that down. So I'm going to say negative 0.75 inches and call that good. And then let's go ahead and apply a fillet. Let me see what size that fillet is supposed to be. So according to EMG's website, so the fillet should be 0.187 on all inside radii. So inside corners, take me a second to select all these. Okay, 0.187. Did I get that right? I missed this one right here. Okay, that's looking pretty good. Let's grab the other ones while we're at it. Keep going. Trying to do this quick. This is tedious parts of CAD modeling. And I still missed that top one somehow. Okay, so I got all that. Hit OK. And we're good. So that part's already done. So we've got the tuner holes, we've got the pickup slots, and we've got the preliminary holes for our potentiometers and our selector switch. Now, one cool thing about having a laminated top, now this won't apply to people who have a unibody style, but cool thing about having a laminated top is that you can actually hide channels behind it that you can pre-route before you glue on the top, which is really cool because then you don't have to take like a long drill bit and drill through each pickup slot or into the cavity. So you can just pre-route those and then cover it up. So what I'm going to do is I'm going to go back to our last sketch and I'm going to make a connecting slot between these. So let's go from here to here, make that midpoint, and let's make this 0.5 inches. Okay, and now I'm going to go back to that extrude where we pulled that in, and I'm going to highlight that. So let me show my sketches. Grab that as well. Oop, I actually don't want to do that. So I need to hide my laminated top, then show the sketch, and do a separate cut down to the same distance. So to object, the bottom of that surface, hit OK, hide the sketch. So you can see I've got a slot connecting these two, and then all I can do is just bring back my laminated top and cover it up. So I've got my pre-built wiring holes, which is great. And I'm going to do the same thing to connect it to the control cavity in a moment. Okay, so now we've got enough information to go ahead and cut our control cavity. So let's sketch on the back surface, and we want to hide our other sketches, this one, for now, and let's bring in this surface, and let's bring in these holes to that sketch, and let's bring in the bottom surface of the bridge. So let's hide the laminated top. See if we can snag that bottom surface of the bridge and project that in. So that way we can kind of see where everything is meant to be connected and we can avoid certain areas. So let's go ahead, and what I'm going to do is I'm going to take these lines right here, project those into my sketch, and now I'm going to hide my body. And I'm going to take these and I'm going to offset them a little bit. So let's go 0.125. That's the wrong direction. Negative 0.125. let's give a little bit more, negative 0.25 inches. Okay. So now, because I did that, if I bring back my body, you can see I've got a little bit of breathing room where the actual cover plate can sit. So I want to go ahead and I'm going to make this one a construction line. Go create arc from here to here. Let's make that tangent. And now I can draw a straight line down. Make these tangent. And I'm going to go ahead and make these. Let's distance this off of the bridge. Give ourselves a little bit of breathing room here. Let's go 0.25, like that. Bring this down. And I'm going to create an arc here that is going to be concentric with the bridge. So concentric, like that. Okay, so that keeps my 0.25 around the corner of the bridge. Now I'm going to create a straight line over. Let's make that, before we dimension that, let's give ourselves an arc to this line here. Make that tangent. Okay, and then let's make it vertical to the front edge of the bridge. Now we need to make these tangent. There we go. Okay, so the only thing remaining is to get this arc tangent. Now this might be a little tricky actually, but let's see what we can do. Come on, work with me here. Okay, can we make those tangent? We cannot. So what I'm going to do is I'm going to draw a straight line out, make that tangent to that line. I'm going to make that a construction line, and then maybe we can make this tangent to that circle. Come on. There we go. So that's not wanting me to make that tangent either, and I'm not sure why, to be honest. Let's see. Okay. Well, what I can do is just connect it to here, and it'll get me pretty damn close. Connect those two. And let's see, I should still be able to move something, it looks like. No, I can't move that. Can't move that. Should be able to move this. Maybe I just give that a dimension. No. There we go. Okay, so it's liking that. So let's give this a radius of 0.75. So let's just go ahead and delete that line, 0.75. Okay, that's going to get me pretty dang close. I'm all right with that. So arc from here to here to close up this sketch. Make those tangent. That seems to be working, but it's not defining it. These sketches are not playing very nice today. Why is that? Okay, let's try this again. Create arc. Actually, you know what? I can just turn that off as a construction line and it'll close the profile. So that'll end up being my back plate. Now the end pin will come in through the side here, right here. That'll leave me room for the other hardware and the, or not hardware, the other electronics and the battery up here. And that should be good. And then I can end up creating a channel that cuts into this one right here. So let's go ahead and do that real quick as well. So let's draw. Let's see, how do we want to do this? Let's look at it from the front because we can see it a little bit better. So we want a channel like this one right here to come into here. And we don't, it's going to be hidden behind the laminated top, so it doesn't matter if it clips off this corner at all. So yeah, let's go ahead and do that. Let's just clip off that corner. So let's go ahead and draw it from here to here, here to here. Let's make these parallel to each other. We got an extra arc somehow. Coincident? Make these parallel. Okay, and now it's just going to want kind of an angle. So let's see. That's probably fine the way it is, to be honest, but actually what I want to do, the more I'm looking at this, is I want to go ahead and move this one to here. And let's see, let's do that. So let's see if we can give a radius, or not a radius, yeah, 135. So it's basically a 45-degree angle. That should work for me. So now what I want to do is I want to cut this up to the laminated top. Actually, I need to do one more step. I apologize. I need to offset this whole shape right here. Maybe minus this arc. Offset. See if we can offset that. No, it won't let me offset of an offset, so that's the problem. So let me grab these ones, offset, and we need to give ourselves a lip so that the back plate has something to rest onto. So let's go negative 0.5, give ourselves a 1/4 inch lip on all sides, and we're going to replicate that shape real quick. So there, down to here. Create an arc around the corner. Okay, let's stop real quick and give it some constraints so it doesn't go haywire on us. Concentric. Hold on. Make these tangent to each other. That's weird. Okay. Sorry for all the goof ups tonight. My computer's, or Fusion's, acting a little strange on me. So make these tangent. Yes, okay, that's what I was wanting. Tangent to here. Okay. These two need to be concentric. That. Then we want these two to be vertical. Nope, that went horizontal. I need to bring it over a little bit. Okay. Can we make those vertical? Yes. Okay. So keep going around the circle. Go create arc from here to here. Now I won't think I have to dimension it this time. I think I can just literally make this concentric. Concentric. Maybe not. Okay, let's make these vertical. As this model's getting bigger and bigger, it's having a harder time keeping up with all the constraints. That's part of the problem. Okay. See if we can make this concentric. Yeah, there we go. Okay, cool. So now we can cut this inner shape plus we need to actually connect this line and this line because we need this channel to go all the way through. Actually, we don't want that channel to go all the way through, the more I think about it. Okay. So let's cut this up to the laminated top. So bring back the laminated top, hide the body. Like that. Up to object, laminated top. Bring back the body so that it's a cut. Hit OK. Nope, I didn't select those circles. So let's bring back our sketch. We want to cut those as well. Okay. Now we are missing some reference in here, and there, that got messed up somehow. So let's redo that. Saying it's over-defined like that. Maybe that's because it's concentric. No? That should work. Those are vertical. You know, maybe, no, that's going to stay horizontal because it's concentric like that. Maybe I can define the distance between these two. There we go, 0.25. Okay. Sometimes Fusion really throws fits at weird dimensions. Hit OK. Did that fix it? Yes, that fixed it. So I no longer have an error on that sketch. Okay. So what we also need to do is cut that channel. So, but we need that channel to actually be on the same side as this, not where I drew it. And I think that's where I was getting screwed up. So I don't think we actually need this at all right here. We need that on the front side by the original sketch. So let's go ahead and sketch on the laminated top, or not on the laminated top, on this portion. And let's connect the top of this arc. I need to project that in. Project and come on, project. I need to project in this arc. So we're going from this point to this point, and then from this point to somewhere on this circle that is parallel to this line. There we go. Okay, and then we should, oh, I need to project these in to close the sketch. There we go. So we're going to cut that down to the bottom surface of the pickup slot. Hit OK. There we go. Okay. So not only do we have the pickup slot, we've got the channel connecting the two, and we have a channel running it to the cavity. So if I bring back the laminated top, you won't see any of that, but you will have the cavity right here. And you can see that you've got that hidden wiring channel right there. So now I need to bring back that sketch. Not that one, this one. And we want to cut this down by the thickness of our control cavity. So I'm going to cut that down another 1/4 of an inch, so minus 0.25. Hide the sketches, and now we have a panel, or now we have a recess for the panel that we can put on there. So let's go ahead and make that panel. So let's create a new component, control panel. Okay. Let's bring back that sketch, and inside control panel, we want to take this sketch and this sketch with all the circles. Bring that down, negative 0.25 inches. Now we should be able to move that in theory, unless I accidentally made it part of, nope, okay, there we go. So right here, I want to join that to this. There we go, hit OK. Okay, so now we've got our control cavity. Not too bad. So the last thing I need to do before we can start installing all the hardware and finish up the guitar is to cut 2 holes for end pins, so that way we can actually have straps on the guitar. I am, like I said before, I am going to be using an end pin jack rather than like a Fender style where it comes out the side here. That just seemed to be the easiest thing for me to do in my design. So let's go ahead and do that. So I need to place my end pin somewhere within this control cavity, tangent to this surface. So I'm going to go construct tangent plane right here. And that's going to go ahead and give me a plane that's both tangent to that corner and right here. So let's hit OK. Sketch on that plane. reorient, and let's project in this wall right here. And what I want to do is I want to find the midpoint, not of these lines, but between here. So let's grab these two lines, make them equal, and let's make the center point vertical to the tangent point of this circle, which is right there. And most end pins are around a 1/2 inch. I think the one that I was going to be using was around 12 millimeter. So I'm going to say 1/2 inch because that gives me a little bit of clearance. So 0.5 inches. And I can make these construction lines. And let's cut that into the cavity. So we're cutting that. We're still in the control panel, so I need to back out of that. I need to come back into here. I need to redraw that sketch. I apologize. I'm still in this component. So let's go back to the body. Create tangent plane here. Hit OK. Sketch right there. Reorient again. Give ourselves our, project that in. And give ourselves our two construction lines. Make them equal. And make this vertical to the tangent point. Give ourselves a 1/2 inch circle, which actually happens to be the distance here. But just in case I ever decide to change the thickness here, I'm going to go ahead and just give it a dimension of 1/2 inch. So 0.5 inches. Okay, so now we can cut that, there we go, into the control cavity. So let's hide the panel, and we want to go up to this object right there. So that's where my end pin is going to be coming in at. Okay, so there we go. So now we have enough to go ahead and start installing all of the hardware and apply some appearances and tidy up this model. Let's bring back actually let's leave the control panel off for now. And let's go ahead and install our potentiometers. So let's go potentiometer into the design. Hit OK. And let's mate this circle right there to the top right here. Hit OK. You can see that's sitting inside there. Now, obviously, when you install it, you could reorient those. So I could do that right now so it's facing a better direction. Let's go 270. Okay. Let's copy that, paste it over, do the same thing over here. So grab this one here, join it to, not to that dot, to right there. Hit OK. And let's reorient that one too so it's pointing a little bit better direction. Okay, now let's grab our knob, drag that into the design. Excuse me. Come on. If the computer ever decides to load. There we are. Okay. Now, I do kind of regret picking a knob that already had knurling on it, because that makes my design a lot more complex and makes the overall design slower to calculate. But let's grab that point and see if we can join it. No, we can't do that. So can we grab this and make it to here? See what happens. Flip the orientation. It should work. Let's see. Nope, it's going into the body a little bit. I didn't make it high enough. So let's bring that up -0.065 and see if that fixes it. There, that's looking a little better. Okay, so let's take that same one. Probably should have done these last, but that's okay. Copy, paste. Hit OK. Ooh, what just happened there? Okay, it's just being slow. Let's grab this circle again. join it to here, join. Probably have to flip the orientation again and raise it up 1/16 of an inch. So negative 0.065 inches. Okay. Now, I need to quickly save this design because I haven't saved it the entire time. Okay, never mind. I thought it was going to take a second to load all that. So we're good. It is weird because as you move the model around, those knurling disappears and then it kind of comes back. Now let's grab our knob, drag that into the design. Excuse me. Come on. If the computer ever decides to load. There we are. Okay. Now, I do kind of regret picking a knob that already had knurling on it because that makes my design a lot more complex and makes the overall design slower to calculate. But let's grab that point and see if we can join it. No, we can't do that. So can we grab this and make it to here? See what happens. Flip the orientation. It should work. Let's see. Nope, it's going into the body a little bit. I didn't make it high enough. So let's bring that up. Negative 0.065 and see if that fixes it. There, that's looking a little better. Okay. So let's take that same one. Probably should have done these last, but that's okay. Copy, paste. Hit OK. Ooh, what just happened there? Okay, it's just being slow. Let's grab this circle again. Join it to here. Join. Probably have to flip the orientation again and raise it up 1/16 of an inch. So negative 0.065 inches. Okay. Now, I need to quickly save this design because I haven't saved it the entire time. Okay, never mind. I thought it was going to take a second to load all that. So we're good. It is weird because as you move the model around, those knurling disappears and then it kind of comes back. See, there you go. Okay. So now we can install our tuners. So I have a couple different styles of tuners in here. It's all kind of based off the hip shot design, but it's got different angles for the securing screw. So let me drag this one in here. Hit OK, and for the time being, I'm going to hide those knobs so that way they don't mess up my model. Now I've got speed back again. Okay, so we want to join the bottom of this shaft to the back of this hole. We want to flip it, and then we want to make sure it's oriented. So do we have the right one, first of all? Yes, we do. Okay, because I want them all pointing towards the body. So this is just for visual purposes, so the angle here doesn't really matter. You'll set that when you install it. So I'm just going to kind of make it parallel to that edge. That looks pretty good. Okay, let me grab the next one. Might do a time lapse here. Okay, so there we go. The tuners are done. Let's go ahead and install the end pin. So I modeled up a brief end pin off some design I found online. It's not really critical to me how it looks. All that matters is that the hole for the diameter is correct. So let me bring that in. Join that to this circle. Okay, I need to find a way to make that concentric. Yeah, there we go. Perfect. Okay. So there we've got our end pin. And now let's install the bridge, or not the bridge, I keep saying that, the pickups. So, pickups. Let's rotate these into place. Okay. So what I'm going to do is I'm just going to make this pickup transparent. Where's my opacity controls? I need to break the link in order to do that, which is fine. Opacity, 50%. And then what I'm going to do is I'm just going to join this plate to the top surface and then eyeball it, only because I didn't give myself the screw holes here, but I'm not going to be making those in the CNC. So I'm just going to be making them, I'm just going to be drilling them by hand when I get to it. So let's go ahead and get this close. Bring that up. See if we can find a center. That should roughly be it. Okay. And let's make this transparent too. Nope, I can't. Okay, that's fine. And then we'll paste a new one. Nope, we still had that copied. Undo. Let's take the transparency off of this. Copy that, paste it over. We're going to do the same thing over here. So we're going to go join, cancel. Okay. Let's make sure we've got this parallel to this one over here. So that, then get that into place right about there. Okay, so there we go. So there's our pickups in place. And let's bring back our knobs. Okay, all the hard work is pretty much done. We've got all the hardware installed. We've got the guitar fully modeled. There's only really two things we need to do. One is we need to apply some fillets to any remaining surfaces that we haven't, and then apply appearances and, like opening presents on Christmas, see what we got. So let's go ahead and apply a fillet. Now, I do already know that the way I did this end pin is going to give me a little trouble. So what I'm going to do is I'm going to find that sketch and I'm going to apply my fillets right before that. So let's roll history marker here. And let's apply our fillets here before the cut.
2 hours later.
Okay guys, I think we finally reached the point where we can apply appearances. And it's like opening up a Christmas present when you finally get to see it the way it's supposed to look. So let's open up our appearance panel. And let's apply our body color. Let's apply our laminated top color. Our fretboard. And our nut. And to the back, let's apply the darker laminated top color. Okay. And there we go. That's looking a lot better. It's looking like a real guitar now rather than my just, highlighted colors for the modeling process. Let's go ahead and open up the render workspace and let's see what we've got. Hopefully this won't take too long to load. All right. Everything is looking amazing. While you guys weren't looking, I secretly added in the potentiometer, or not potentiometer, the switch that I forgot. So that is now in there. And wow, I am really, really happy with how this guitar turned out. I hope you guys like it too. It's certainly right up my alley. It may not be everybody's taste, but I certainly love it. So thank you all for joining me on this journey of how to build a guitar in Fusion 360. I realize that this has taken a long time to get to this point, but I finally have a guitar model that I'm truly happy with. And a lot of that, as weird as it might seem, is thanks to you guys for putting up with me and me learning a lot, including better ways to do the headstock transition, better ways to do the neck transition, and overall, I ended up with a much better model than my original. And I'm really happy with it. Everything's a lot cleaner. And a lot of that, again, is thanks to you guys and this video process that we've been going through. So check out my what's next for this channel video that I posted today. I go over what my thoughts are on where I'd like this channel to go. So I think going forward, we're not going to be doing guitars as much, although I am certainly open to doing more guitar work, especially if you guys have a particular model that you're trying to do and it's not working for you. But again, thank you so much for joining me on this journey of how to build a guitar in Fusion 360, and I'll see you in the next project.